So the last idea seems a little new, but it's really not. Just it's the notation that is. And what we're asking for is, in these problems, I'm giving you the arc length. So I'm telling you, S is pi over 4, pi over 2, or 4.333. So how many radius lengths are along the edge, right, that lie on a unit circle? And again, we're still going to start in standard position at 1, 0. And what we want to know is what's an ordered pair, an xy, that lies on the terminal side. Well, remember what we've just found, right, is when r is equal to 1, theta is equal to s, right? And when I'm on that unit circle, every xy coordinate, no matter where I am at, right, x is the cosine of s, and y is the sine of s. And again, there's 1, 0, and there's the theta, and there's your s. So we're really just reinforcing what we did at the very beginning of this journey. Because we're on the unit circle, because my angle of rotation is equal to the arc length along the edge, the x and the y coordinate on that circle is basically the cosine and the sine value. So we're just redoing what we have. So what's my coordinate pair here? Well, the x coordinate is the cosine of pi over 4, and the y coordinate is the sine of pi over 4. This is a 45-degree angle, so we're talking about the square root of 2 over 2. Of course, if you don't remember that, you can just come use your little cheat sheet, and we got it, right? So there's pi over 4. There's your x and your y coordinate, respectively. So again, we found for a 45-degree angle, or for a pi over 4, right, arc length, x and y, right, the ordered pair that satisfies all that is the square root of 2, square root of 2. So we got it. And I guess maybe to be official, right, there is our ordered pair. So same thing here, right, our arc length is now pi over 2. So our x coordinate is the cosine of pi over 2, and our y coordinate is the sine of pi over 2. Well, that's 90 degrees. We know that the cosine of 90 degrees is 0. We know the sine of 90 is 1. So we're talking about 0, 1. And of course, if you didn't remember that, you can go to your cheat sheet. So there's pi over 2. So if I rotate angle pi over 2, or if I do an arc length of pi over 2, right, what's the x and the y coordinate that is on the terminal side? It's 0, 1. So cosine and your sine value, respectively. The unit circle is not going to help us out here because 4.33 is not a exact, right, radian measure, but we can still use what we're using, right? What's the x coordinate? Cosine of 4.333. What's the y coordinate? The sine of 4.333. And so we definitely need to bust out our technology now. We're basically looking, let me get those inverse out of there, the cosine of 4.333 is equal to that. So our x coordinate is negative 0.370. It looks like 4, right, if I round to 4 decimals. Let me clear that out. The sine value, right, our y value, is the sine of 4.333, right? And that is also equal to a negative 0.92, looks like 89. And relating this to the unit circle the best that I can, right, 4.33 rads, well, 1 radian's about 60 degrees, right? 2 radians about 120. 3 radians takes us almost to 180. And so 4 radians definitely takes us into the fourth quadrant. And since we're in the fourth quadrant, notice that the x and the y values are in fact negative. So our x value is like a negative 0.37, and our y value is negative 0.29. So it's probably somewhere down in here, right, where that data point is. So 4.33 rads, right, would be walking that far, or our angle of rotation would be that far, since theta and s are equal to each other. So we can still use the unit circle to kind of visualize what's happening for that, which may or may not be helpful to some of you. Hopefully it is. It just reinforces the whole concept. So there you go. So we now have all our definitions. We have an XYR definition, we have a right triangle definition, and we now have a circular function definition for sine, cosine, tangent, cosecant, secant, and cotangent. And obviously we're going to do so much more with all this stuff now. So obviously that's going to come in some more videos and some more sections. If you have questions, please make sure you're asking. Jump on Canvas, pose your thoughts, put your ideas down, put your homework things down. Give me an opportunity to give you some feedback before you take those all-important quizzes. If you're really struggling, please hit me for an office hour. If you can't hit my Zoom office hour, ask for an appointment. I'm here to help you, but you got to reach out for that help. You guys keep pressing on, and I'll see you in section 3.4.